Let us study the relation in electric field and electric potential. As we already discussed, if there is a region of electric field, an electric potential is a characteristic property at every point of electric field. Say if I choose a point P in the electric field, there exists some electric potential at P, which is given as work done in bringing a unit positive charge, that is plus 1 coulomb charge, from infinity to this point P, which was the definition of electric potential we have defined, that is work done in bringing a unit positive charge from infinity to point P is the electric potential at point P. So if we bring the unit charge from infinity, then at any point we know in the region if electric field is E vector, this will be the force experienced by the unit positive charge, and if it is displaced by a distance dx in bringing it towards point P, then we can say work done in bringing a unit positive charge from infinity to P is, this is defined as potential at point P, which is written as integration of E dot dx. It is a work done by electric field in displacing the unit charge by distance dx in its path. We put a negative sign, this will be the external work done in shifting the charge towards point P by dx, and we can integrate it from infinity to point P. This is the expression for electric potential we can calculate by using the electric field. The same we can use in various calculations which we have done earlier, like if we talk about electric potential due to a point charge in its surrounding, that also can be calculated by using this method if there is a charge Q. We already discussed that at a distance R at point P, the potential can be given as KQ by R. The same expression can also be calculated by using this result, because when we bring a unit positive charge from infinity to point P, potential can be written as negative of integration. Electric field in its path at a distance x can be written as kq by x square dot dx from infinity to r, because point P is located at a distance r, and at a distance x we have placed the unit charge which is brought towards the point P. Now in this situation you can see we can omit the dot product because external force and displacement are in same direction. So here Vp can be written as kq integration of 1 by x square can be written as minus 1 by x, but this minus will also cancel out. So it will be 1 by x limits from infinity to r, and on substituting limits you know the result will be kq by r. So we have calculated the same result by using this expression where we are relating potential with the electric field. Vice versa can also be done. Let's continue on the next sheet. As we have discussed, we can use that in a region if E vector varies with position x, then relation in electric field and electric potential can be given as, we have just now written dV can be written as minus E dx, or E can be written as minus of dV by dx, and if we just use vector forms then it can be written as E dot dx, and E vector can be written as minus of dV by dx in the direction of x, which is denoted by placing a unit vector along x direction, that is I cap. This is a relation we use, and it is similar to the relation F is equals to minus of du by dx I cap. If you can recall, we have studied in conservative force field the relation in force and potential energy. So here we are talking about relation in electric field and potential. So electric field is the force on a unit charge and the V potential is the energy, interaction energy of a unit charge. So both of these results are almost identical. And in continuation, we can also state for three-dimensional variation in electric field, we can use E vector, we can write as minus gradient of the potential in the region, which is also written as minus gradient of V, or this can be mathematically written as minus of del V by del xi cap plus del V by del y j cap plus del V by del z k cap. I hope all of you can recall the same expression we have studied as a relation in force and potential energy for three-dimensional variation and force or potential energy in a region. So this expression we use whenever electric field varies on all coordinates of position of a point, and this expression we use on when electric field varies only with the one dimension of position.